Hello, my name is Mark Christopherson, and this is my Explainer 2 video. So my question at the top left here was draw these structures as wedge dash, name them, and assign all R and S values. Here, as you can see, I was given these Newman diagrams. And then below, I actually use ChemDraw for these, but we'll go over that in a bit. So from the first one, I initially started with just drawing it, and this is what I came out with in ChemDraw. It looks a lot neater than the one I did on paper, and we can actually compare this against the Newman diagram. So we have a CH3 here and a CH2, so that would be my CH or C2H5. Then we have back here, we have a CH3, which is here, and we have our chlorine. And the arrow here designates how we're looking at it. So this is kind of going to the right. So if we shifted it, that is why this methyl group is pointing towards us and the chlorine is back. And then you kind of go to the back part of the Newman diagram, whereas bromine is up and towards me, which is this right here. Hydrogen is away and up, and then the other C2H5 is back. And that gives us this shape. So that is the wedge dash. So now for naming, so you count the carbons 1, 2, 3, 4, 5, 6. So we have a hexane, and we have a chlorine group and a methyl group, and then a bromine. So you count 1, 2, 3, 3 chloro, 3 methyl right here, and then 4 bromo. 4 more goes in front just because of B. And then we can get to the R and S. So our 2 chiral carbons are right in the middle here. Chiral, as they all have different substituents on each end. They're all unique anyway. And so for naming these, we have the Ingold-Perlog system, which in the top right here is a simple way to go about doing that. The first step is assigning priority based on atomic numbers. So for this particular one, we have carbon here, carbon, carbon, chlorine. Chlorine has the highest, so that is a number 1. And then it's essentially pair, or on the opposite side of it is our CH3. So you can designate 1 and 4. The next gets a little tricky when you try to get to 2 and 3 to get this correct. And it's hard when it is drawn with the number 1 back without having a 3D model. So what I thought and what I kind of do is when I see this, I imagine this chlorine actually kind of shoots back this way. Right? Because if you think about it in a 3D space, that would kind of make sense. Instead of, or you could also try to like flip the molecule like an omelet and try to reorient everything. You could do that as well. But if we imagine this chlorine is drawn back here, we would have, and then we can orient that. Next, assign the other 2 priorities is here, we would have a carbon that's attached to a bromine, and here we have carbons attached to 2 hydrogens. Bromine has the highest, so that is why this is a 2 and this is a 3. And if we superimpose chlorine back here and we do the steering wheel method, we see it goes clockwise, and clockwise gives us an R, so 3R. Now for the next one, for our bromine, it's the same kind of thing. We know bromine is higher than carbon, so that's number 1. Its pair is hydrogen. And here's kind of the same thing. This one's a little bit easier because it's pointing towards us and it's already has the lowest one pointing away, so to speak. But you go, this one has a carbon with 2 H's and this one has a CH3 and a chlorine. So this one is going to get the higher priority here. Now, if you point this like up towards us, so this can be kind of a little different as well. Because if you just like shift the model, like the left side of it kind of goes back and the right side goes forward, this is going to go, and you can actually kind of see like this, it goes like this, backwards, which gives us a counterclockwise, which is S right here. Okay. And that is that one. For the next one, we can go through and kind of skip going over the Newman diagram, but I kind of drew it like this to really replicate the Newman diagram. It looks really janky, but it does the trick. And here, after we get it drawn from the Newman diagram, we can go ahead and count 1, 2, 3, 4, 5. So we have 5 carbons, so we have a pent base, and then we figure out what is the biggest. So we have a ketone group here, and this is just an amino group, so ketone supersedes that as well as the hydroxyl. So we would have a 2-one denoting a ketone on the second carbon. So then we can kind of go with groups. We have 1, 2, 3. There's our 3 hydroxyl. And then we have 1, 2, 3, 4, our 4 methylamino, because a methyl group off an amine. And then it just continues the group. So that's the base of this. Now for the 2 chiral carbons to determine the RNS configurations. Again, we'll just start with the first one to us, which is the hydroxyl group. So again, assigned priority based on number. Oxygen beats carbon and hydrogen. So that's number 1. Its composite is H. And here, since this one's pointing towards, it's a little bit easier. Our 2 ones, they get priority here. This is a carbon that's bonded to a nitrogen. And this one's a carbon that's bonded to an oxygen. Oxygen has a higher atomic number. So actually this gets the priority over this. So you would have 1, 2, 3, and that is counterclockwise. So that would give us an S configuration, which is down here for the 3S. And then for the next one, the 4, which is in red, we have our nitrogen. This is one where you got to kind of do the same thing. And for this, I just kind of like superimpose the nitrogen group back here. So once then, we'll just kind of draw a little end there, and then we look at our other groups. So here, this one has this has just a carbon, 3 hydrogens. Over here, this has a carbon with an oxygen. So this is our higher priority here. So that would give this the 2 and this 3 here. So then you would just kind of draw towards this. And that gives us another counterclockwise, so we have another S. So that's a quick little down and dirty. It can get a little complicated when you start having several things that tie, and it's kind of the same, there's the same rhythmic manner. And this is actually found on page 220. It goes over a step-by-step guide in the book on how to approach this. There's 2 different sets of rules. You have the first Ingo-Perlog system, and then you have if there's like the tie-breaking system and how to assign priorities below that. All right, thank you very much.